aspect. You're supposed to be able to be able to share your screen, but I don't exactly know what I'm supposed to choose, and then I don't know how to get back out of it either. So I wouldn't mind doing that at another time.
Well, I have your images if you want to bring them up, if you want to talk about them.
Yeah, because otherwise it's probably real simple to share the screen here. I don't exactly know how to do it, but
yeah, you know, when you click on the share screen at the bottom, generally it shows you all the different windows that you have open, and then you can click on one of those windows and share that. But on an iPad, I'm not sure what it shows.
I don't know how that works. It just another thing I have is, why does it?
More people coming here. Admit all. All right. Let's see.
This should be selecting it.
That worked. Yeah. That's your Civil War picture there, huh?
There
I didn't realize you were in the Civil War, Tim.
Oh, you have a Civil War picture?
Earlier.
Oh, yeah. It's not Civil War. That's Sergeant Garcia from the old Zorro days. And so there's an app that you can use.
Doesn't start till tomorrow.
Huh?
Civil War doesn't start till tomorrow.
Yeah, exactly. No, there's an app you can switch your face with somebody, and I did it to a buddy at work. I took the old Sergeant Garcia face and put his face into it, and he got really upset with me, so I did it to myself. And it's fairly funny. I'll definitely get together with you, Tom, and try to figure that out. If I do it tonight, I'd be afraid that I'd really screw something up.
Well, whatever you did, you just shared it fine. So.
Mm-hmm. Oh, really?
Yeah.
What shared? The Civil War picture?
Yeah. Yeah.
Oh, that's weird. I didn't do anything over here at all.
Yeah, you look just like you always look, Tim.
Yeah. Yeah. Oh, well.
In a uniform.
Yeah, you know what, Tom, if you want to go put that image up, that would be good right about now, because it's, you know, it's fine. But if Mike shows up, he's got that image. He has already seen it. I'm using an app on the iPad here. What I'm going to do is I'm going to send these images over to the Windows computer I have, and I have an old version of Photoshop that was kind of a freebie, and I think I can remember how to manipulate them, so I can kind of make one transparent and put an overlay exactly over where I want it. I can use a scaling tool that works really well. The app I'm using right now is called Art Studio, and there was a previous version that was pretty easy to use. This one is insanely difficult. So I got really lucky here. What you're seeing here is the greenish is really an image that I took with the iPhone of the mirror I have, the 8-inch mirror now.
You know, the whole thing looks greenish to me.
Yeah, it is, but the more clear dark lines.
Yeah, the real sharp lines, the broader ones.
Yeah, that's the overlay. That's really it's a Ronchi-gram that Tom sent me from a program he called Mac Ronchi.
Yeah, so that's the target you're looking for. You're trying to get there.
Yeah, exactly. And I have to say that this R was probably 79 point. I think it was 79 3/4 inch. That value for R, and right now I'm at 81. So I'm going to have to redo that. I have an image from Mel Bartel's website, but I kept trying to do the same thing with it. I would take that image and then crop it and I tried to use the images I had with the iPhone and overlay them and make one translucent. It was a big mess. It just didn't work. So I'm going to try to do it.
this shows that you're still undercorrected, but you've got a good edge.
Yeah, I agree with that. And the images that I don't want, I would love to share, but I'm afraid that I'd really screw it up. The outside are images that I have. And what I found out, I think I told you guys that I can't get a full disc outside R with the iPhone. It just won't work, because the reason is because the Ronchi screen isn't close enough to the LED and the camera. It's too far away. So what I did is I took the whole Ronchi grating and I took it outside the window and kind of leaned it up against the camera, and it works a little bit better. But when you see the image of that, you really can see outside R that I'm well undercorrected still. It's a good, yeah. Especially the 70 zone, and outside R, it shows that from 70 out. Well, actually, it's actually pretty much all of it. So I'm going to just continue to do the same parabolizing stroke and hope that I don't screw it up. I contacted
that's the right approach. It looks to me like it's you're sort of uniformly not corrected, not fully corrected.
Right.
From this one picture, I wouldn't pick on one zone that is being bad.
Yeah, and what Tom Whittemore was telling me is that the stroke to use is I have a sub-diameter lap.
Right.
This is an 8-inch mirror, so I have about a 4 to 4.5 inch lap.
Mm-hmm.
And he says, just keep the edge. Start it. Let's say you're starting over on the left edge. Don't take that tool over too far over the edge, because you'll turn it. And he's just
how far did he say was too far?
If you go an inch over, I think you're too far.
About an inch is what you said?
Yeah. I think what he was actually saying one time, just take the tool, the lap,
yeah,
and take that left edge of the tool and match it with the left edge of the mirror. And then as you start your stroke, and you're using that W stroke, that's a parabolizing stroke, right, with a sub-diameter lap, just follow the edge up and down with that W as you go across. And he was actually trying to suggest not going over at all. Just get up to the edge and stop there, and then go back down to the bottom, stop there. And then there was a point where he said, well, if you do that, you might not be affecting the 100 zone, the 98 right, zone. So he says, just slightly go over there.
He knows you have a love affair with the turn down edge, so he's just trying to steer you away from that.
Yeah, exactly. And Jerry, if I do that again, it's gonna be a disc that's gonna roll down San Marcos Pass Hill. That's what it's gonna be. Because
I think a little overlap and the parabolizing step will get you there. Just be patient. The sub-diameter lap means you're going to take a longer time.
Yeah, it goes really slow, and I haven't seen any correction. And I put a good 60 minutes into it the other day, and I just didn't see any correction. So the lap is getting pretty thin now. I think it's down to about 3/16. So I may have to be shooting Tom a ring and do it and make another lap.
Yeah.
I hate to do that, because it's everything, when I press out for long periods of time. I may even put the lap on top of the mirror hot and go away and watch a movie and come back and then start. So it's a good hour. Okay. So anyway, that's it for that. It's coming along real slow, but at least it looks like the edge is okay.
Yeah. Good luck.
Yeah.
Just stick with it. You'll get it.
The other thing that I was contacting Mike Chibnik about was he sent me was the bath interferometer. We've been threatening to make one of those for a long time. Yeah. And he sent me a 10 millimeter beam splitter. So I have that on hand. And the questions I had for you tonight, Jerry and Mike, if he was here, anybody that knows this, Henk probably knows this stuff. you're going to need to take an image of what you're looking at. I'm just assuming I can use an iPhone or a DSLR,
Yes.
but then you need a beam splitter, then you need a lens, and then you need a single surface mirror. What I don't know is how large does the lens have to be, and is it going to be a double convex surface, that type of a mirror? I mean, a lens
Surface.
And
You know, the different focal lengths and diameters of the lenses, the speed of the lens you're talking about is going to determine the speed of the mirrors, the range of mirrors you'll be able to use it with. So there's a couple of websites, I don't remember where they are right now, but I can look for them again. And they go over that of how to figure out the different components, what the spacings are and what the recommended focal range are. But you can make almost anything work.
okay.
Yeah.
But the diameter of, like, let's say take the single surface mirror, is it going to be something that's just like an inch wide in diameter?
I
Or is
don't
it-
call that.
Yeah. Say again, Jerry.
I said I don't recall the size of the recommended size of the mirror.
Yeah, that's kind of where I'm stuck right now. The other thing
But
is
most of the diagram, most of the bath interferometers that are on the net are for large mirrors, 20-inch or 30-inch or something, because it's a common technique for big things for professional mirror makers. And the size of the components in the interferometer are not that large. So you can make the smaller stuff work. You just have to move them out farther or in farther so they catch more of the beam. These kind of things that Tom is showing now, these are not to scale.
Okay.
But you can just put them to scale. You can make your own scale drawing by looking at where you want to put your mirror and what the diameter of the mirror is. So that gives you how far apart the two red lines are out there.
Okay.
It's just geometry. It's not hard to do.
The next part of this that I've been reading on is the 3-axis stage that you're supposed to be an XYZ stage.
Yeah, the one that he shows there made out of wood, and then 3 scissor, what are they? Scissor jacks.
Yeah.
That's very clever. I like that, and it's cheap too.
Yeah, I've got to find something cheap. There's a site that you can get it's a 3D printed 3-axis, the parts of it for about $15. The whole kit itself was about 40, but there was one site that recommended not even using a 3-axis stage. Just don't even do it. And this guy was saying you can do it with just with the real fine threaded screws. And so I started looking that up because he was suggesting you want to get something that's like a 1/4 inch, 1/4 by 40 at a minimum. The most I could find was a 1/4 32 from McMaster Carr. But Thor Labs.
I thought we'd worked out the size of the components that we wanted once before.
You might have. The ones that one guy used were from Thor Labs. But when I went to Thor Labs, and I've got stuff from them, I got a 1/4 80 screw. That's what's on Tom's test sheet that I built for him.
That takes you forever to move anything.
It's just too much. It's too much, and I'm almost thinking I could settle with a 1/4 32 because I tried moving that 1/4 80 screw. You can't even see the threads. It's so small. I have a couple of those left, but I don't know. I'll figure that all out. And Mike and I'll get together at some point and come to some kind of conclusion of how we can build one with that scissor rim.
I'll dig up my notes and drawings on it too.
That's a really nice image there.
Oh yeah, that's nice.
Tom, if you could send me a link on that, I'd appreciate it.
Okay, it's actually some kind of wiki, some group IO. Let me see. I'm gonna go back, I think, to the main page. I'll send you the main page. Go back.
That's something that looks like I could make.
Either of those two would be good.
Yeah. But it's, you know, there's a fairly, there's a free software program you can get too. And I'm almost positive I could use it on with XP. Hi, Mike. It's so that's what I think I'm going to go for. And then I'm just going to try and run it on this XP machine that I have here. I'm pretty sure it'll work.
Astrophysics sells a reasonably priced version of the professional software for reducing that data.
Oh, really?
It's on the astrophysics website.
Oh, okay. I'll look for it.
Okay, well, I'll look for it too.
Oh, thanks, Tom. I see the link. Thank you very much.
Yeah, it's in the chat box.
Yeah, I appreciate that.
All right.
Yay, got it. Okay. I'm gonna
Mike,
go
I
try
like your windmills there.
yeah.
My daughter shows us where the windmills are doom.
Can't say
I
much
should
for
say, I
fidelity.
should say that there are the windmills of bad seeing.
Okay. There we go.
The picture of Tom, AKA Tim Crawford down there, that looks like Martin Meza. You know, he does reenactments, and he does the reenactment he does is a pre-California, you know, Mexican soldier when Mexico ran California.
Did it show up again?
Yeah,
Yeah.
When I left the screen, it showed up?
it sure did.
Holy cow, I don't know how that happens. Yeah, that's Sergeant Garcia from Zorro days.
Yep.
Have any of you guys been to that miniature museum across the street from Harvard
The sound is coming across garbled, Mike, for me.
okay.
Yeah, for me too.
Okay. There's a miniature place where the situation for California was signed, and it's what's that amusement park in Hollywood? Universal Studios. Okay, and there's this. It's part of a small villa, and a little bit still left, but they have reenactments every year. They have a celebration, and they have mariachis and reenactments of the capitulation.
Yeah,
It's
your
not going to happen for a
voice.
while.
Your words
Mike,
are very
Mikey.
garbled. I can't follow it. It's harmonically distorted or something.
Yeah.
You
Okay,
need,
let me go and try and change my audio here.
I think maybe if you just turn the volume down, it's just overmodulated. If you can do that. Yeah, mic volume.
Okay, how about this?
That's better.
Yeah.
Okay, that's the laptop.
yeah, there you are.
Okay, you'll notice I have a different look also. I had a couple of these, and there's a slot in the bottom. They're the Wise cameras, the security cameras. They're only
Yeah.
$20 a piece. And due to the COVID situation, they have a download that converts these into a webcam.
Into a what?
A
Webcam?
webcam.
Oh, webcam. Okay.
I'm using the webcam now instead of my my laptop.
That's pretty
It
good.
seems to be doing a better job.
Are you in Kansas?
Yeah.
Looks like he's down near Palm Springs.
Yeah, exactly.
No, this is Montezuma Hills, just outside of Rio Vista. There's like about 400 windmills, and
Wow.
I bike right up that area there. I can go on a like a 46-mile trip and only cross one stop sign, one stoplight and about 3 stop signs. And it's in the middle of nowhere. I got other pictures I could show too. Sometimes I have to stop because they're herding sheep or cattle or something like that in the roads. Sometimes it gets kind of dicey too because you'll have like 30-mile-an-hour winds and try and bicycle up a steep hill in 30-mile-an-hour winds. So. It's no fun. Well, I do it anyways, so it must be fun for me. But anyways.
So Mike, you missed just a little bit. I shared that overlap image of the Ronchi-gram, but then we also discussed a little bit about the Bath interferometer, and Tom left a link in the chat that has a pretty good little. It has a pretty nice picture of something that somebody built, and that's something I think you and I can get together with on sometime
Right.
and figure out what kind of lenses we need. And
Yes.
but that's where we do. I was talking to Jerry about what size lenses, what size of the single, front surface mirror we need, and he's going to look for some.
I've got the mirrors. When I sent my mirror out, it was, I chose the more expensive place because they did the diagonals for free. And so I had a couple of small mirrors, aluminized from Surplus Shed. So,
Oh, nice.
yeah. So I have most of the stuff. It's just a matter of me getting off the computer with clickbait and sitting down and doing it.
I think that 3-axis.
I thought we had designed that just about the time Mike left. We had decided on something and on sizes and things, but I guess we hadn't got those yet.
Well,
I gave you a beam splitter.
yeah, I have a 10mm beam splitter, but what I don't have is I don't have the lens or the front surface mirror. I don't have those, and of course I haven't even started that 3-axis stage. That's something that this thing that Tom sent, the link, has a really nice looking picture of something somebody built. Definitely something we can handle because it's made of plywood and it's probably aluminum. So
yeah, I tried that link. I got page not found. So that link is bad somehow, I think.
There's
oh, really?
I think I know which one it is. It uses aluminum extrusions and the board and some large screws. I'll try and send it to you if I can find it.
I was telling Jerry that I was reading one article where the guy said, "Don't even bother with the 3-axis stage." He said, "Just use screws." And I don't exactly know what he was talking about, but he says you really don't even need them.
Well, basically the forwards and backwards and sideways you can do fairly easily. It's the vertical that becomes a little bit more difficult to do. I suppose that if you had a very sturdy tripod with a vertical crank, but it needs to be very stable.
Yeah. And I also told him that the screws that I had some that I built that with the tester that I did with Tom. It's like a 1/4-80. I'm definitely not going to use those. It's just too fun.
It's they use the normal hardware that I think they use threaded rod from the hardware store.
Yeah. The finest I can get is about a 1/4-32.
Yeah.
I wish I could incorporate the handles from a micrometer. That would be really slick in one axis that you really need. I have an old micrometer here that I could probably garbage, sacrifice, and if I can get the handle off. But I'll check it out. But that would be really slick.
I forget where I got it. It used to be that you had all these surplus places in the valley that you could go and scrounge and get all sorts of goodies. And I think from one of them, I picked up about 3 of the, and I'm looking for it now, and I'm rifling through. They're basically the screw mechanism that fits into the C clamp, you know. They got the thing that goes this way.
Yeah.
And it, I got a couple of those. I think they're good for a 1/2 inch of travel.
Right. But ever since Joe retired from MRL, we're kind of missing the dumpster diving that he was doing. He was picking up some really cool stuff.
I miss Raytheon. I miss working for a regular place where, you know, they throw away scrap, you know,
Yeah, you're
hardware
right.
and scraps.
The tester you had was, what was it? That thing was really slick.
Oh, that was a
There it is, Mike.
Oh yeah, there you go. Yeah. Yeah.
So that actually looks like something I can handle.
Yeah.
I don't really understand I don't really see the Z axis unless it's the one to the
It's
far
on
left.
the other side.
It's
Oh,
on the other side.
Okay.
Yeah. So
Well,
basically, yeah.
That's pretty neat.
There it is.
Yeah.
It's pushing
Oh.
up from the bottom.
Oh, and he has a spring on it,
Yeah.
right?
The slide part is missing.
Yeah. To apply some tension.
So how are you
Okay.
supposed to interpret these diagrams that you might get?
You digitize them and you put them into a piece of software.
Yeah.
And
it part of the I've been reading this website for a long time. There are a lot of things that can trip you up. Like one of them is getting the proper contrast and also the proper number of lines, and also around the circumference. You need to go and properly frame it, otherwise you'll get wrong results. Now these guys, the way that they talk about things, it's sort of like they're getting into the minutia, which kind of makes you, kind of scares you, because they're saying, well, you're going to use a lens. Well, it can't be a double convex lens. It needs to be a plano-convex lens. And then, you know, they're talking for like 4 or 5 days about, well, how do you go and accurately measure the lens? Because you could be off by 1/10 of a wave, you know. Yeah, you know,
That's exactly what I brought up to Jerry. And there was one site that I was reading where the guy used a double concave lens, and he said, "Oh yeah, you can do that too." And I just got lost.
No, but these guys on the website, they're like uber optical guys. They're you know, like Jerry with PhDs, and they're talking about all sorts of constants, Zerk constants, and they're referring to papers between 10 and 50 years old, you know, and how things get derived, and so it gets a little scary. But I think for us, if we're accurate to within 2/10 of a wave, I think any of us would be very happy with the results, or 1/10 of a wave or something like that. Yeah.
Yeah.
Yeah, that other thing you have.
I'd be very happy with that.
The scissors jack, you know, a lot of people use it, but they don't tend to be very stable. I actually have one, and it kind of rocks around a bit. And one of the things that you have to do is you're moving things forward and backwards and sideways and up and down. And you need to move your camera with it, because this is not a visual instrument. It needs to be imaged, and you have to be careful that the laser doesn't shine too much in your eye because you could hurt your eye. So, you know, I always thought that you mount the assembly on the dust cap of the lens of a DLSR, mount the DLSR in the X, Y, and Z, and move that around and use something like a live view to get your results because it's you're moving things only a small amount to get it to where you're supposed to be, and then you need to move your camera exactly so it fills it up properly. So,
And I forgot, there's one other part was the laser. You need a 650 nanometer laser.
now what's important is you know what the frequency of the light output is, the wavelength.
Yeah.
Okay, if you don't know that, then you don't know. I mean, things could be off because it's scaled.
Again, you could, again, the parts that I looked at from the Thor labs for those
Yeah.
screws,
Yeah.
they also have a 5 milliwatt, 650 nanometer laser for about $13. And then you just have to wire it with the right resistors and everything. I am terrible at that. Hank, I'm going to have to call you because it's going to be something that's going to be right up your alley.
Yeah,
What kind of resistors to use with this wire and where does it go? Because I'm going to get lost.
if it doesn't have its own internal driver, you have to be very careful about lasers. Because I've worked with them quite a bit in fiber optics. It's like at low current, it's like an LED, and you raise the current a little bit more, and the light current goes up like an LED, and then all of a sudden, bam, it goes up to maximum, and you can burn out the laser. So make sure that they talk about a proper laser driver. Otherwise, you could damage the laser. Now you can.
Are we talking potentiometer? Is that you're talking about a potentiometer?
A potentiometer, but you a lot of times what they do is most of these lasers have a photodiode in the back. It's a little bit more complicated. They have a back pickup off inside the cavity where the laser diode is, and they use that in what is known as a feedback loop to keep the output level. In other words, you're adjusting the light output with the output of the photodiode, which is kind of telling you what the amplitude is. And once you have that set, okay, it's a set and forget, unless something goes wrong with the circuitry. But,
okay.
But in a pinch, if you go from zero current and go all the way up to where all of a sudden it starts lasing a little bit, then you should be okay. I've done that, but I've also burned up lasers myself.
Okay.
So I know about these things, and when I was working with them, they were like $350 to $600 a piece for semiconductor laser diode. Oh yeah, the ones. Those were for fiber optics, you know,
This little guy from Thor Lab seemed like it was plenty good. It was just, you know.
It might be. It might have the circuitry inside it or be designed such that it's forgiving.
I'll send you a link of that when I get a chance.
Yeah.
So it had the little 3 prongs in the back and the little laser capsule. And
a lot of times they use keychain lasers.
That's what I'm thinking. Yeah. I have one that I used in the workshop that kept on kind of shorting out. It had bad contact on it. It's just plastic, and all I got to do is take it apart and take the innards out.
All you have to do is make sure that it doesn't have shine it on a wall and see that it's pretty much circular. I think that's the only thing you really have to worry about.
Oh, okay. Well,
if you take a look at most of those Wikipedia things, they're describing the lasers, and half of them are keychain lasers. So we're able to use that.
Okay, well, I've got my work cut out. That's for sure.
Well, so do I, because I've got all the parts and not put them together.
All right. Well, that's it for my end, Tom. I'm set.
Okay. Who wants to do a different discussion? Anything that want to discuss? Hank, do you want to do your polar alignment at all or discussion?
Yeah, sure, I can do that. That's a short one. It's well, it's a show and it was a show and tell presentation at the RTMC quite a while ago. So you'll have to allow me on my laptop. So I'm clicking on Zoom to join. Should be automatic, right? I clicked on your link. It should now be. I don't see anything. Oh, yeah. Okay. Yeah. Video preview. Join with video. Well, join without video. It's got a lousy. Do you get me?
Not yet.
I think you got to do share screen. The bottom.
I think he's trying to sign on with a separate.
Oh,
Yeah.
okay.
I'm waiting for Tom to accept me. That's
Oh, okay. Hold on. Sorry. All right.
it says please wait the meeting host. Yeah. Connecting. Okay. Okay. Share screen. And then I want to share my desktop. Let's see
Your
here.
twin.
That should be this guy, I think. Let me join with computer audio. Just okay. So join with computer audio. Fine.
You need to turn the audio off on one of them.
Oh, now they're both off.
Another UFO, huh?
So Tim, I think you really did a good job on that mirror of yours.
Yeah, talking to Jerry. It sounds like it's undercorrected. I'm gonna go. Oh, I've seen that. Yeah, we're seeing it now, Hank.
You haven't got any audio. That maybe both things are using the same mic or something. Maybe.
Yeah, Hank, your microphone shows that it's off.
You're muted.
Yes, I'm.
Yeah, no sound yet.
No, he's trying to do it without getting the feedback.
Yeah, we're not hearing you. We'll let you know when your voice comes through. Maybe we should practice reading lips.
I don't see any of them. Oh, there they are.
I was watching Planet of the Apes earlier. I saw one thing is like that. Something
Okay.
like that is thank you.
Which
Should
one
be
are
okay
you
now.
watching?
There you go.
Planet of the
Yeah.
Apes. They were talking. They were signing to each other. So I was trying to memorize some of the signs. You know. Just,
I heard Hank then.
Yes.
oh, he's back on. Yeah. Okay.
We should be okay now, I think.
Yeah.
Yeah.
Sorry about that. All right. So this is the corny. I did put this together at the RTMC. It was only a 5-minute thing. So polar alignment is for astrophotography always a big problem, at least in most cases, for me apparently. And there are several ways of doing that. So polar scope is one, but I don't have a polar scope, and even if I had one, I just don't like to have to look up to the stars and drag my neck. It's just, I actually had one on my LXD55, and I didn't like using it at all.
They make them with a right angle viewer in them.
Yeah, well, that would be actually not a bad idea. I didn't know those existed. It could be very practical.
Yeah.
But anyway, we always like to make things more complicated than they really are. So let's just continue. So drift alignment, I have never tried it, frankly. I know that it takes a long time. I get the idea, but it doesn't seem very attractive to me. Then there's ASPA. I've tried that. I have an AVX mount, and that's kind of cool. I mean, you do the go-to alignment first, and then when you're done with the go-to alignment, doesn't mean that you are necessarily polar aligned. So then it figures out from the position of the stars and how it got there through its internal coordinates, where the polar axis should be placed, and then it tells you move to a star, and then you start the polar alignment procedure. It moves it a little bit, and then you have to center that star with the alt-az controls, and that works. The only problem is that after you've done that, then you have to redo the go-to alignment because you've changed the polar axis, and so it's an iterative procedure, and you end up spending a lot of time. So it's just not practical. You're better off doing the polar alignment first before you start, and then doing the go-to alignment once, and then you're done. Sharp cap is pretty good. It is based on the idea of rotating the telescope and finding the RA axis as it finding the location in the sky where your RA axis is pointing by a rotation around the RA axis where your telescope is pointing. So, and that's an interesting idea. So that's a pretty smart method. And pole master is similar to that. It's also rotation based. And let's see here. So I'm kind of opposed to using too many computers near the scope. So I was trying to figure out how can you do that without using a computer. And so my thinking was, well, if I have a little camera, I got my Astro camera. What I can do is I can, in order to find out where the RA axis of my scope is pointing at, I can just hook up the camera to the telescope, and then I rotate the telescope while taking a picture of 30 seconds at 6400 ISO. So then you get the star trails on your camera, and the center of those trails will tell you exactly where it's pointing at.
Question?
Yeah.
So the very first step, aim the scope at Polaris, do you mean with the index marks for RA and DEC zeroed out, and then, you know, move the tripod around until you got Polaris in there, or can you actually use the RA and DEC, you know, of your mount to find Polaris for that step?
Well, usually if you have Polaris in sight, that's an assumption, by the way, that's not always valid, but in my case it is, for most people probably. You have to have Polaris in sight, and that's, you know, most people when they set up a telescope is they sort of aim it at Polaris so that the, you know, 1 foot of your tripod is aiming straight at it. What I used to do with my AVX is it had an opening for a polar scope. I didn't have a polar scope, but I could just use the opening, eyeballing through it, aiming it at Polaris. It's really not that difficult. So you can get a rough start if your, you know, tripod is somewhat level. Then you can use the alt dial to set it at 34.5 degrees or something like that. That's accurate enough. If you look through the hole and then move the tripod left to right a little bit, you'll get it in
Okay.
pretty soon. And what you can do after that is just mark those positions with tape on the driveway or wherever you are. And then next time you set up, you set it there, and then you're probably good enough. But you're right, that is, you know, the initial position is a bit of a problem, because one of the limitations of this method is that the scope field of view is usually about 1 degree, and that's fairly wide actually already. And so you have to have Polaris in sight, and when you do your rotation, the polar, the northern celestial pole actually has to be in sight. When I say Polaris, I should actually say the northern celestial pole, because that's what it's all about.
Okay.
So usually after you've done it once and you put the scope back in place where it was, then it's fairly easy to do again. But yeah, the first part, especially if you possibly have like a a cone error, that would be a problem because then you can never exactly get the NCP at the center. It doesn't have to be at the center, but it makes it harder. So there's a lot of gotchas there. But let's forget about that now and assume that it's all fine and we can do RA rotation and we've got the northern celestial pole somewhere on the LCD. So, no, actually, sorry, the first problem is to get actually the RA axis on the LCD because, of course, you don't know, you have the declination rotation. So if your declination is off and you do the rotation, the center of rotation might actually be outside the picture that you're taking. So you have to get that right first. But once you have that, then you know where your RA axis is pointing. So then from then on, you keep the declination axis fixed. And then you start taking pictures. And let's go to the next slide. So this is, for instance, the result of your RA rotation. So this big white line that is Polaris, that's the brightest star around. And the RA axis is pointing at this red dot. You don't see that on the camera, of course. I just painted that in there with Microsoft Paint, but you get the idea. You have to have that center. It's usually fairly easy to eyeball. And the scale of things, this is 40 minutes, right? Just from the Polaris to that red dot. So you can do that fairly accurate to like 2 arc minutes or something. Here's the camera. So I've got a piece of tape that I have. I just stick that to the camera and there was a white dot on it. I used whiteout. Later on, I replaced it with just make a little hole with a hot needle, and that's actually a more accurate marker, and it doesn't wear off. Anyway, so you stick that on there on the LCD screen, and then you start taking pictures. So this is the same picture. You don't see this on the camera, but here you see an asterism overlined with it. See those 5 stars here? 1, 2, oops. Oh, I click and the slideshow goes on. Okay. This asterism here, so it's this star, they have names, but this is an asterism that's fairly recognizable. And Polaris is right over here. So I just aim from here to there, that line, and then a rectangle, perpendicular line from here to there. That's where Polaris is at. So then I need to move that point.
Why doesn't Polaris show up in your picture?
Sorry?
Why doesn't Polaris show up in your picture?
Oh, sorry, Polaris is right here.
Yeah, okay.
Oh, okay.
Yeah, so no, but we need to have the northern celestial pole, right? Okay. So that's here. So this is the asterism that I'm trying to describe. So this green dot here is where the northern celestial pole is. So with a bit of experience, you can recognize this thing. I can see it visually. If I put a 30mm eyepiece in it, it's actually even better if you use a 9mm, because then, or you add a Barlow, because then the background gets darker and you have more contrast. So that would work. Of course, 30mm gives you the widest field of view, so it's best to start with that. With the camera, you can set it to like 3 seconds and you've got plenty of stars and you'll see this. Anyway, so then you start moving the axis and you start taking pictures. So every 3 seconds, you move it, take another 3-second picture. As you can tell, I've moved it over here. So we've moved a little bit to the right and here, almost there. Okay, so here, too far, back a little bit. Yeah, now we're in the left to right position. We're pretty much there. So you also have to align your camera so that, left to right corresponds with left to right in the sky. That's the easiest. Otherwise, gets a little harder. Now then, up and down. Let's see here. Okay. Well. Anyway, you try adjusting the alt as, and after like a couple of pictures, you got it right. I'm almost there now. Too far down, and here. See this. It should be. This one is pretty much right. Yeah. Okay. So that's where it is, and at this point, you're polar aligned. I'm overlaying it with the original one. It's about 2 arc minutes off here. So that's fairly accurate. Anyway, that's it. Did I make it clear, or is it?
Oh, I understand it.
Yeah, that's good.
Yeah.
Anyway, but it's a fun way of doing the same thing as what the Pole Master does or what SharpCap does, except you don't use a computer, just a piece of tape and a marker on the tape. And
what kind of tape is that, Henk?
Just clear tape.
It's okay if you stick it on your DLSR, not going to hurt the screen.
Oh no, not at all. I don't put it on. Oh no, yeah, it doesn't hurt the screen. No.
Okay, thanks for the presentation.
Yeah, thanks.
All right.
Very
Now,
interesting.
I have a question. Chuck does something. You were talking about the sharp cap, and Chuck does something where he kicks the legs of the tripod around. Is that kind of like the sharp cap?
No, that's just an iterative manual thing that I did with my 9 1/4 inch.
Yeah, but
But
this is the sharp
when
cap.
you-
Is some.
Well, I'm not sure what the sharp cap does, but what I'm doing is I set my setting circles to 232 plus 8916, which is the coordinates of Polaris in J2000, and get it centered in my finder scope, and then go to some other thing like, Altair that I would know the coordinates of 952 plus whatever. And when I'm on Polaris, I only do manual movement of the tripod and the declination or the latitude adjustment.
Mm-hmm.
Then when I'm on the star, when I go and center the star, then I change my setting circles to match what the star should be as close as I can, especially in RA. And then I go back to Polaris, and then I do the physical moving of the tripod, and then I go back to the other star, and
So this is what Henk was talking about, the iteration that he didn't.
right.
So when Henk's doing that, he's doing this really on his DSLR screen, and you're literally moving, but you're taking these pictures over and over, and you're moving. But what I don't get is how are you moving Polaris over? Are you?
That would be the manual controls on the mount, I would assume.
Yes. So once you've got your the center of the tracks, that red dot over there, and you're taking pictures, then you take a picture and then you move the Alt-Az controls of the scope. You don't. You don't use the deck or the RA. Especially the deck has to remain fixed after you did the rotation. Don't use the deck, and there's just your Alt-Az controls and move. The camera such that Polaris, I mean, this northern celestial pole coincides with that asterism green dot.
Interesting.
Yeah.
That'd be interesting to try.
So I can tell you, I've been using sharp caps, so I can tell you how that works.
Oh, go ahead.
Yeah, so I set up my tripod, get it as level as I can, level it all out and everything. Just take a regular, pretty decent compass out there, and when I put the mount on there, I get it, as sort of close to Polaris as I can. And I've gone out and I've sort of seen where it is in the sky, and I try to do this in the day, as it's before it's getting dark. Later part you have to do in the dark, but the initial parts, and so I can kind of line it up that way. Have the scope on there and everything. Then I put my guide scope with a camera, and I use a ASI 120 mm. It's a monochrome, sort of somewhat, more discount scope. It's like $120 or something. I'm sorry, camera. And that's hooked up to the computer. So you start up Sharp Cap and you say, start polar align. And so once you've got it set and you've got the guide scope somewhat focused, it actually, the interesting thing is you don't have to have it that well focused, because it's going to centroid all the stars. So it doesn't have to be super precise, but you want to be able to see the stars. Then it says, please wait, and it does plate solving. So it's doing plate solving, looking at the field of view, looking where the stars are. And then it goes, okay, got it. Rotate your scope 90 degrees in RA, either to the right or to the left.
The tripod legs?
No. Just the RA, you unclutch that, loosen the RA adjustment, and you swing it 90 degrees, and you click, it tells you click next button before you do this and everything. So you click the buttons at once, then you click it, and it sits there and it goes plate solving. And all of a sudden it goes bang, found it, and it draws a big green vector, and it says, here's where you have to move you know, and yeah, it just tells you. And so you start moving and it's giving you how many, you know, arc minutes or hard seconds of error that you have. And so it's kind of cool. So I usually start with RA adjustments, and I'm doing that, and it's, you know, you do it in that direction. It keeps plate solving, keeps redrawing that vector. Then you go, okay, it wants to go down with the declination, wants to go to the left with RA. And then eventually you get it where you're just barely moving those hand adjustments on the thing. And I get it within like 10 arc seconds or something of you know, where it wants. So it gets it really precise. Then from there you go, okay, done. And then you go to your 2-star alignment or whatever. This is with an AVX mount that I do it. So yeah, it's kind of cool. And I've got it down where I can do it in about, you know, 10 minutes or something.
You know, where I preset up to try and polar align for outreach, I do it during the light of day, and I also have a compass that I find the magnetic north, roughly.
Yeah.
But I have to stay so far away from my scope, or my mount, because there's so much iron in it.
Yeah.
Oh yeah. Yeah. Yeah, I found that out. In fact, I use 2 different compasses and kind of compare them. And then I know just the angle off from north that I kind of want to be. I think it's a little left of north or whatever to get Polaris.
Oh, the declination?
Yeah. And then I check what I've done by going over and asking Chuck where the pole is.
Yeah. Yeah. No, actually not in declination then for the magnetic, but for left, right. So in azimuth, I'm you know, I'm looking at just a slight off azimuth of, you know, from where the compass is telling me.
That's our 6 famous words that I don't know. Let's ask Chuck.
And sharp cap, I like that. And then I've been getting into it with picture captures too. And yeah, it's kind of a neat tool. I've been using mainly that, and then PixInsight for the processing, which is still a lot harder to learn. But I've been using the live capture. I haven't used live capture with a scope, because you can do live capture after the fact with like a folder that has 100 images or whatever, and it'll go through as if it's viewing them one at a time, and it'll start I'm sorry, not live capture, live stack. It'll start stacking the images. So it does a live stack. That live stack thing is, and they have revised that thing so you can do all sorts of, you know, settings on that of you know, tweaking this and that. But if you just use your basic settings there, you can do a really nice live stack of images, so, you know, as they come in. So it's a pretty cool, pretty nice piece of software, I think.
Javier has one of those Revolution imagers, you know, pretty cheap. I think it's $200 or $300 for a 7-inch monitor, plus the camera, plus, you know, power supply and cables and things. And it does live stacking. So the longer you sit on a target, the better the image gets. And it's actually fairly decent quality. It's not quite like the Mellencam, but it's, you know, for 1/7 or 1/8 the price, it's really a good buy.
Yeah, I'm eager to try it with a sharp cap, because then, you know, the old way, you just take a bunch of pictures and you hope that when you stack them, they're nice. This way, you know when you're looking at it, if it's going to be good or not. So,
well, between each one of the individual frames that you take, is there any dithering that you do?
You can set that. Yeah, you can either turn it on or not. You know, it depends on if you want it. Yeah, you know, like in Auto Stacker, when you know, that separate one, I use that, but it's either off or 1.5 or 3.0 for the, or I'm thinking a drizzle. Anyway, you can, there are a bunch of those settings. There's settings I haven't explored yet in Sharp Cap in terms of obviously exposure and time and everything like that. You know, you have some idea of what you want to do with that. But, and, you know, in that one for the Astro cameras, there's no ISO, but there's gain. So, you know, it's kind of the equivalent of the ISO. So you have to know where you want to set the gain on that. But it really depends on the target. So, but I each night I've been going out. Last week we had the Tuesday thing, and I think I went out a night after that and 2 nights, but it's just been so cloudy and everything, and it hasn't been good. So
it was a very small window, and then it closed real quick.
Yeah.
So, but Chuck, what you mentioned, that is more for like a video camera, right? It's not really for an astro camera.
Right. It's a video. It's a live outreach video camera really is what it
Yeah.
is.
So the quality is pretty low quality then, I guess, right?
640 by 480, you know.
Yeah. So, but Bob, what you described for SharpCap, you started out describing that it works for your guide scope camera.
Yeah.
But when you stack, you want to do that with the actual imaging camera that you have,
Right.
right?
Right. I'm doing that with images. When I've done planetary, the astro camera I got is meant for planetary, but I'm starting to, you know, I have two of them. I have that. The one I'm using only for the guide scope. But the one I'm using for the pictures is the now I'm going to forget the number. ASI
120?
Think of it in a minute. Actually, I get the box right here. But anyway, it's a color camera. That when I'm doing the individual images, when I do planetary, it seems better to use video for that. So I take certain video exposures and then I stack those later in Auto Stacker because that just takes the whole video file. In fact, it'll take multiple video files if you want. And
Yeah,
stack
but that's
them
completely
together.
different. That's completely different, right? Because that's lucky imaging. So you
Yeah.
sample at a high frequency. That's not live stacking. So the live stacking
No.
that you do is with an imaging camera. But anyway, I'm just wondering if you can get the same quality as with DSS. I mean, if you do like deep space objects, not planetary.
I don't know.
like to
I've
believe-
seen people that have used it and got, you know, you just look online and they get some pretty, you know, depends on the camera and the Bortle index and, you know, all of that. But yeah, it's I think it's kind of a neat trick. I mean, it's technology advancing. So, you know, it's doing so much of the work, you know, for us now. Plus you can do in SharpCap, they're showing the histogram there. You can click in the upper right corner of that histogram there. There's a little like a lightning bolt or something. You can click on that. It'll do an estimate of a stretch on the image if you want. And so that's kind of interesting. It's got two of those. So there are a lot more features on there than I've used yet. So I've been, you know, I played around with that somewhat. But so far I've used SharpCap just for not doing it live, actually doing the live stack out there, but I want to try that. But I've done sort of a simulated live stack like that with just a bunch of images I collected. So
yeah. Well, I think I'll feel more comfortable with DSS because what DSS does is it takes all your individual subs and it first registers all the pictures and determines all the stars, its positions, and so on, and all kinds. It gives a quality score to each of them, and I have a feeling it's better to go through the whole batch so that you decide to do what you've got, and then you use those settings to go over it and stack everything.
right. I guess
works
that
pretty well.
with SharpCap is doing as it stacks them is it's looking at the background too and figuring out where the noise is. In fact, that's where the I guess the drizzle setting helps to move off a little bit. So it isn't interpreting the noise as real stars or anything. So just with that, it's really helping with the background though, I think but Deep Sky Stacker is great. And I was using Deep Sky Stacker and I kind of switched over to Auto Stacker because it'll do that whole rating of images too. And then you can take whatever percent of the top best images you want for the stack.
Yeah.
You know,
And the other thing is what do you do with darks and flats, because you have to do darks and flats, right, to get
Yeah.
decent image.
SharpCap has that. You go out, you do your darks and darks. Yeah, darks, flats. I guess I think you can do bias too, but you do those. I've got that set up now. Again, I'm just getting going on with that in the last week. So yeah, it's I don't know. It's just it's kind of an amazing tool, and you know.
Right, but it can't do the darks and the flats live, right? It has to do that. You have to do that after the fact or something like that. I mean,
yeah, you can do them. I was doing flats before because I was doing the T-shirt against kind of a low light, like near sunset, and then it actually shows you a histogram and it tells you, no, I need more light. No, I need less light. It's actually showing the histogram for the flats of what you want, which is kind of cool, you know. So you're actually getting an accurate flat, not just like you're guessing.
Yeah. But then you're not live stacking anymore, right? I mean, you have to take the.
Oh no, I do that before. You do that before the fact, you know. So like you do your whole setup. You know, the darks I would do after the fact, I guess. When
Okay, so you can take your flats and tell SharpCap, well, here are my flats, and just use it when you're stacking.
Right. Yeah. For, you know,
Okay.
say later I'm going to use that. And then same with the darks. The reason I waited on the darks too is I wanted the temperature of the whole setup to be right, and it's cooling down as it gets darker.
So,
I
so
don't
do
think
you
that
take the,
it doesn't matter
do
with
you
the
take,
flats, but
do you take the darks before you start the live stacking?
so far all I've done is taken the darks, and then I was getting ready to do some imaging and all the clouds came in, so I haven't done anything. So yeah, you can do it. You can do it before or after, but
Okay.
That's
yeah.
when you would do your flats.
Well, I think if it's fully dark outside, you need some kind of light source to do the flat. So that's why I wanted
Flat light source.
yeah, I wanted to do it sunset, you know.
Yeah, what I do is I just aim my my telescope at the wall and nothing in front of it, because it's out of focus anyway. So you can just shoot ahead, and it always works. I have
Yeah.
a white wall that is about at 4 meters distance, so I just aim it at that, and it never fails. So
Yeah.
it's really
Yeah.
easy.
The thing that I saw though that I liked was that histogram telling you in SharpCap of what the, you know, where the flat exposure should be, and so you just adjust it a little bit, you know, to get that right.
Yeah.
Auto
Cool.
Stacker, I believe, also is able to do flats and darks.
Yeah,
If you do it
and bias.
beforehand,
Yeah.
too.
Yeah. So anyway, I like that tool. It's
Excellent, excellent.
yeah.
It's all Greek to me, but I'm getting there. I'm following it. This astrophotography you guys are doing is like magic to me. It's unbelievable.
You know what I
Yeah,
might
you can
do
do it
is
in a,
try to, I'm sorry, go ahead.
you can do it in a very complicated way, Tim, and also in a simple way. When I started out, I just used a DSLR hooked up to the AVX, and I let the AVX do everything. But nowadays, you know, a lot of the astrophotographers use a lot of some computer support, like what I use with my Raspberry Pi ECOS. It has plate solving and everything and so on. So it aligns by itself. I mean, it can. I'm not using it right now, but I know it can do it.
I like that. I like that method you used with the DSLR with the tape. That's really trick.
I personally, I like to keep things simple and be able to do everything manually as much as I can.
There's a beauty in simplicity. There's a real beauty in
And a computer is a pain in the neck, because you have to put it somewhere, you have to walk around it, you have to find the keys and all that. It's just not much fun altogether.
I'm going to start with the moon. I'm going to use DSLR and the moon, and even the iPad, the iPhone, because I showed you guys that iPhone gadget that I have. That's kind of cool. Once you get it all set, you can just rip them off. But I'd like to try the DSLR as well. Wow, I'm getting a cramp.
Yeah. By the way, so when I did the SharpCap thing for Polar Line, I just tried this once now and I wasn't successful. But well, first I just did some images with that, but then I was trying to get better guiding, so I tried to use PhD2, you know, with SharpCap. And what I didn't know is when you use the Celestron AVX mount, and
Chuck, you're morphing.
It's what?
Oh, Chuck is morphing there.
Oh, okay. I think you had to connect properly. It had not connected properly to the camera for PhD2, and then I watched some videos online, and I guess you have to use that CPWI Celestron program first to get the camera, and you have to know the exact focal length of your guide scope. That's really important. And then PhD2. Once you get all these things dialed in, then PhD2 can do it pretty quickly. But it wasn't working for me, and I go, why isn't this working? And I realized I wasn't doing things in the right order. But so
what program do you use to control your camera?
What do I use? Or for the camera, I was using SharpCap. That was right in the replace the eyepiece with the ASI camera, ZWO ASI camera, and then that's running with a USB 3 straight to the computer, and then I get that all pointed and focused and everything. But I want to take longer exposures, so I've got to use a PhD2 to guide the thing. And I just tried this 5 days ago.
PhD2 is very, very compatible with nebulosity. Have you tried that?
I've just found out about nebulosity, and I'm going to try that instead of nebulosity. That's where I'm using PixInsight after the fact. So yeah.
I have
Nebulosities to control the camera and
Oh,
take
okay.
the images. You know,
Okay.
exposure time and
Okay.
time to dither and stuff.
Yeah,
Okay.
but
Yeah,
I think
I have nebulosity, but I don't use it to control the camera. But it also has a stacking capability, and I kind of hated it. It just the whole interface is just horrible. I bought it because I wanted to do something back to the author of PhD 2. That's Craig Stark. He wrote nebulosity and PhD 2, PhD actually. So I thought, okay, let me just buy nebulosity. So I don't have a guilt complex for using PhD for free anymore.
Yeah.
But I hated the program really. It's
It's my
complex.
go-to program. It's so easy to use. I've never had it screw up. Captures the pictures very nice. Controls.
Oh really?
And it seems to have every camera I've ever had in it. So
Okay. No, that's great. You know, I didn't use it for actually doing the imaging. So if you say that works very well, maybe I'll try it once I get an Astro camera.
Jerry, isn't that fairly expensive? Wasn't it about $250 or $350 now? Or
I don't know, when I got it, it was $149 or something like that.
oh, okay.
Huh.
But I saw your
Nebulosity
results with
I
that
don't know what it's
nebulosity. It
got
was
now.
neat. Hey, listen, guys, I'm fading fast. I want to show you one thing here in the screen. I don't know if you can see it. Probably not. Let's see.
take
You're
your
disappearing
background
behind the
off.
moon.
This right here
Oh,
is what they call a cam clamp. This is the latest thing I've been building as a tool for building guitars.
Oh,
And I don't know, it's kind of hard to get in there, but it's a pretty simple device. You know, you're using aluminum bar and then some wood. And
getting dominated by your background. If you turn your
Yeah,
background
it's not
projector off,
working.
you'll be able to see it better.
Yeah, it's not working out. Let's see if I can get out of that. There.
Here you
See
go.
that?
Yeah, that's better.
And it's a fairly simple device, but I've made about 6 of these guys trying to perfect it. And it's this area here where you see the right here and here. Whoa. There and there. That area there is where you have to put 2 pins, these spring pins. And the device is fairly simple. It just spreads apart like so. And then when you bring it together, you pull on the cam clamp and that tightens everything. You can see how it springs the little slot right here. It was a fascinating thing to build, but it's something that I've been goofing around with. They're fairly expensive, and you can make a bunch of these things for a couple of bucks a piece if you do it right.
looks like
What
you
is it-
use
what is-
some nice hardwood.
Yeah, use hardwood. You can use oak. I use some cherry I had sitting around, oak I had sitting around. I think this is something I had. I think it's called quilted maple.
Hey, Tim, before you go too, you reminded me with the moon background. I saw this video during the week here. This guy, he has a YouTube site called Astro Biscuit, and he's in London. He's a pretty funny guy. But so this thing is called the Blue Lake on the Moon. So click and save that link or whatever when you watch this later. It's about, I don't know, 15-minute thing, but it's pretty interesting. He was trying to image this thing that Apollo 17 found on the moon that they call the Blue Lava Lake on the moon. It was very interesting to me. It's like
I think this is actually one that I took when we were out at Westmont, and I was using the iPhone, that iPhone tray that I got, and I ripped off about 20 of these things one night. So it turned out pretty good. But
okay.
For me, that's great.
Yeah, I think this guy was trying to image it with like a 10-inch Newtonian scope or something like that. So it's, which he thought was going to be impossible. He thought maybe you couldn't even get it from Earth or anything. But this guy, I like him because he's trying to do astrophotography on a budget. He's trying to do things pretty cheap. So he's pretty interesting. So I think everybody would find this kind of funny because he bought the telescope used. And he went and bought it, and then he put it in a side room and put a sheet over it because he didn't want his wife to find it. He knew she'd be upset. He had bought another telescope. Yeah, so that part is pretty funny too. So
well, I have an old Rebel DSLR, and of course the 10-inch that I built, I tried to put it on. I tried to use it straight through to take pictures of the moon, and my focus was too far inside. So I thought, well, that's it. I'm never going to be able to do that. But somehow it went online and found some. It was either extension tubes or something that I used in combination. I'm going to have to go and try it again because there's two tubes I got together, and it actually allowed me to take pictures of the moon. It was really cool. But the problem I had was cranking my neck behind the live screen. I just hate that. So it's really nice to have one of the DSLRs that have the little screen that you can fold out and move around. And somebody told me, everybody's been telling me, just get a computer and set it up so you can do it right off the computer.
Yeah.
But this was a real quick thing for when we were out at Westmont. You could just like set the thing up and just take a bunch of pictures. And of course, we always had people come by with the moon and they saw me take a picture of the moon. Can I do that? And you get a line with like about 30 people in it and every one of them wants to take a picture.
Yeah.
So anyway, guys, I got to check out. I'm fading fast.
Good night, Tim.
Okay.
Good night, guys.
Good night, Tim.
Thank you so much.
Hey.
Hank, thanks for you see you all
Hey,
later. Hank, thanks for the nice little demonstration.
Yeah, that was pretty good. I have a question to the general public about using Deep Sky Stacker. I have an issue with high sky brightness, getting it to work. Have you guys run into that issue also where if you take a look at the raw image and you can say, oh, I can just barely see that galaxy. All I need to do is add up more images, and it just doesn't want to find stars to
You can
line.
when you're registering the images, you can tell it how many stars to use, and that will sort of filter that, I think. Yeah, it might be if it's bright enough, you're picking too many stars or something, but you can I forget exactly where that is, but I think it's during the registering of images. There's when you go to the settings.
Oh yeah, there's a slider or something like that.
Yeah. Or you can manually enter the number, or you can use
I still have some issues with that. Unfortunately, here there's way too much sky brightness. So, oh well.
So no, I'm curious. What is the problem? Because I use Deep Sky Stacker a lot. So what I do see is, well, okay. So for my DSLR that I use, I cannot go over 1 minute because then the sky becomes so bright that the quality of the images is not good enough anymore. But generally, after you've stacked, then oftentimes the resulting image looks kind of grayish and not very much contrast and so on. But that can all be pulled out, really. It's just the visual representation on the screen, but all the information is usually in there. So you can either do that with Photoshop or GIMP, or you can use the editor of Deep Sky Stacker itself. It has a very efficient editor, actually, where you can very easily, it's pretty powerful, actually. It's very simple, and you can get 90% of the way. If you want to get something better, you have to go to something more sophisticated. But what exactly is the problem? Is the sky is too bright, or can?
Yeah, it's bright. It's bright over here. There's a lot of stuff in the air because we're in a valley. I'm in the San Joaquin Valley, which is one of the most polluted places on Earth as far as air. So
it's not really a Deep Sky Stacker problem, but it's really a problem of the sky.
Yeah, right. And usually you work around it, but if the sky brightness is too high, there's a guy named Samir. He's from Qatar or some other place in the Middle East. He talks about short exposures, going deeper, but that and he can show how you get wonderful results, but it's making sure that Deep Sky Stacker only looks at stars and not hot pixels and other things. If there's not that much in a way of contrast, difference between, because I can see, I can see, like the nebula or the galaxies there. It's just that there's not enough above board to grab onto a star in relation to the
You
sky.
mean it's having trouble identifying a star or a hot pixel or something?
Star. Yeah.
Star. But
And
it
I
could-
can see them. They're not very well defined, but I can say, oh, there's the stars, and they're in all the.
How close are you to critical sampling in your image? Does
What do you mean by critical sampling?
two pixel elements on a given star is critical sampling? Are you oversampling or undersampling?
I might be. Well, I'm using my C8 or my GPS 11, so that's 80 or 110 inches with 4 micron pixels.
Okay, well, I can't do the arithmetic in my head, so.
Yeah.
But if you're undersampling, that could be a problem.
Okay. Well, the other thing is getting Deep Sky Stacker. It used to be that you could easily manually stack things. You could manually, click on the stars to stack them. It doesn't seem to.
That's how I do it, to avoid any confusion. I select the stars, at least 7 per frame, distributed around the.
But you can do that on Deep Sky Stacker?
No, I do it on CCD stack.
Yeah.
So.
Mike, what kind of camera are you talking about?
Well, they're Canon type cameras. I have a 40D and a 600.
What ISO do you normally use? Like very low ISO or a higher one?
Oh, I use the lowest I can.
For good
'Cause
dynamic
otherwise,
range.
You get the dynamic range, and also the noise goes up significantly.
So I just opened Deep Sky Stacker and just put some image files, no darks or flats or bias. But if you go.
Oh, you know what?
So
Correction.
if you go register check pictures, assuming you got these other things in there,
Yeah.
you go under advanced here, here's the
Yes.
star detection threshold. And then you go compute, needing this. Okay, it found 2 stars, so, you.
Yeah, but I don't think that's, I don't think that's the problem.
No. Okay. I thought maybe this would help. It's like,
I've futzed around with that, and then it tells me the stars, and then later on it says, I give up. I'm only going to use one image. You want to use it or not?
oh yeah, that's no good.
No.
Oh, that's pretty bad.
Yeah,
Really?
I think you got to do a batch processing on the images and something else.
That has never happened to me, I have to say. I mean, Deep Sky Stacker, when I try it, it's always pretty good, and it's very automated. So if all your images get rejected, maybe there's a tracking problem. That's one good reason to reject images.
No, not with the Misu. I mean, even unguided.
Yeah, I'll look through my notes on that. I taught a class in DSS about a year ago at the museum. So but I don't use it, so I'm not up on it again. But I'll look at my notes and see about if I can find anything. I don't completely understand your problem.
I know, I don't either, because if I should be able to click on the things to get stars manually, and it just won't let me.
Okay. I'll look at that.
I've never done that. I didn't know Deep Sky Stacker could do that.
Used to be able to on the older version.
In the older versions, okay. I wasn't aware of that, and frankly, if it exists, I wouldn't use it because the stacking usually works so well that it would be extra work.
Yeah.
So if you're interested, next time I can show you a brief demonstration or slides on how to take pictures from space.
From space?
Yeah, so that'll be our next brief thing.
Okay.
Let me see if I can show you something right now.
Which reminds me, I was watching that show on, what's on Amazon Prime, I think, called Away, and they're going to Mars. And so this woman's on a cell phone talking to her daughter, halfway to Mars. And I'm like, yeah, right.
Yeah, it's all instantaneous talk. Yeah.
Yeah, exactly. Exactly.
Let's see. Can you see this?
Oh, yeah.
Mhm.
Okay, that's a picture taken with a camera that I built for Japan's weather, or JAXA. And this was launched in 2005. And there's Australia. And it's centered on the South China Sea because that's where Japan's weather comes from. And this was taken just a few months after the big Banda Aceh tidal wave that killed 250,000 people in this area. But this was with a camera that I designed and we had built and launched. And I can show you the ideas behind that, because we do it a little different for these kinds of cameras than we do for taking pictures of space from Earth. We don't point a big focal plane array at the Earth from up there. We scan the whole image, and it takes 28 minutes to scan this image and make this pattern or this image.
Just puts
So
them all together.
What's that?
It just puts them all together, all the sub images.
Well, no, there's no sub images like that. It's a linear array. It's a 100 by 1 array, and it scans perpendicular to the 100. Yeah, so
Okay.
like that. So
Yeah,
there's
looks
quite
great.
a number of lines that go across there. They don't go in a straight line. There's an arc and a curve to them because each pixel has to come out with it has to fit into the pattern. So there's no, as they call it, keystoning, which makes them into little trapezoids. So you have
Oh
to,
yeah. Keystone effect.
yeah. So and then each image is time tagged, and then it's sent to Earth. No processing occurs in space because it's too risky. And so
Yeah.
then we put the image together in there. But I'll show you the hardware that we made and the designs and stuff.
So if it takes a couple of minutes to take a picture, then the position of Earth will have moved, right? Do you correct for that, or is this just for geostationary satellites?
It's a geostationary satellite. This was 23,000 miles up.
Okay.
But for, I believe it starts up here, it ends down here. So this, what you see down here is 28 minutes later than it is up here.
Ah,
Right.
I remember for Veers, that thing, it would take, smaller pictures and then assemble them all together. And because of that keystone effect, it had a thing called bow tie removal. It would calculate how to remove these bow ties of the thing flaring out at the side. So yeah.
It's a stage that happens in your camera too. It's called resampling, because when you do stacking, for example, you are going to stack the image, and the stars may line up in each image, provided you've dithered, but the pixel doesn't line up with the pixels in the other ones. So the stacking has to recalculate what that pixel would be like. And that resampling algorithm is the most secret thing that companies keep from each other about how to do that. So that's the only thing I won't tell you. But we can do that next time.
Yeah,
So
if you
Jerry-
take images of the stars, then those stars will actually rotate, right? Even if you're geostationary, the Earth will be in the same position, but the stars will have moved to different positions if you take it over.
Yeah, because we're locked up, just like, same rate they move on Earth.
Yeah.
Yeah.
All right.
So Jerry, wasn't there a big deal about taking a full picture of Earth from space? That the Al Gore satellite that finally went up is called like Discovery or something, and that was like, I thought, like the first full image of Earth that they were sending out there in space. They'd get a new image every day. So is that was that a unique? Do you remember that at all about that?
No, I don't. There's been, Landsat has been taking low resolution images since the 60s. And it turned out that it was such a hit in the business that because of financial firms that wanted to trade commodities found that it was an invaluable tool to go over and have certain pictures taken of cornfields during the year in Iowa, for example, and based on the spectral response of the cornfield, they could tell if it was going to be a bumper crop or a bad crop. And so they'd invest and make a lot of money on how that outcome came out to be. So they called it, because of that, they pressured Congress, and Congress, to the great annoyance of NASA, has labeled it the Data Continuation Project. And that means that every year you must take exactly the same types of pictures with the same resolution and the same spectra. So there's no advancements in those satellites at all. You could do a lot of things much better, but it must be taken exactly the same way as the first Landsat satellite. So, and no one wants to, NASA tried to sell it, the whole process in 2005 before I retired. But they couldn't find a market for it. No one wanted to buy it. If you want a specific picture of somewhere, they will do it. Landsat will send the satellite over and they will take a picture for you of the area you want. And it's it used to be in 2005, it was $50,000 per shot.
Wow.
But the thing is that these Landsat pictures come in, and then for the financial firms, it's worth it, because $50,000, 1,000 times is trivial compared to what they're going to make. But most people are interested in the cool pictures, and so people would give them away as freebies and stuff. So there's no market for them outside of the financial industry. And for that reason, it was an unattractive business to buy. So they keep getting stuck with it a year after year, having to do it for the government as a government service. Interesting sidelight.
So just, it's making me remember with Veers, that's up there now, I think about 10 years ago or something, but it's, I think it's mainly weather, but they're sun synchronous. So it hits every spot on the Earth twice a day. So
Yeah.
that's how the sun synchronous works. So.
Yeah, I was a system engineer on Veers.
Oh, okay. Yeah.
So it's a very demanding and very, it has 18 different color bands that it looks in from visible through infrared.
Man,
the Jammy, the one I showed you, was a visible only image, but it has that visible band and then it has 4 infrared bands.
yeah, the Veers pictures I've seen are just unbelievably sharp.
Yes, it's an incredible machine. They've got a constellation of them up there now, I think 6 of them.
Yeah.
We send the instrument, the camera that we make, to Ball Aerospace, and they integrate it into the satellite, and then United Launch Alliance launches it.
Did you work on that through Raytheon? I think I asked you this in the past, but
yeah, I worked on it both through SBRC and Raytheon.
Okay, yeah.
Hughes and Raytheon, yeah.
Yeah, when I was at SAIC, we had a contract for about 4 or 5 years to do the software verification for NPOs and Veers. So
okay.
You see this story here? It says, I guess here. Oh, it says it's a different satellite operated by Japan, and low pressure system, 100-mile-an-hour winds, and waves higher than 45 feet over the open water.
Wow. Now that's
well,
that's not the satellite that I just talked about. We did that. It's a long story. I'll tell you the history of it.
Okay. Save for
there
next
was
time.
just a wave off of Greenland somewhere, I think, that they measured at 67 feet.
Wow.
They're supposed to be getting 20 to 25 foot surf, I think, up north. Like,
Point Conception up there, I think.
Yeah, like right now, I think. So
yeah.
The other day, the CHP got called out because there were 80 cars blocking the Dos Pueblos southbound off-ramp from 101 because of the surf.
Yeah, all surfing out there.
And up here in the Bay Area, 2 kids and a father got swept away by sneaker waves because of the action.
Yeah,
I read about that. That's in Sonoma County, right? That was pretty sad.
Yeah.
That's right.
Up here.
Okay, well, I'm going to check out.
Yeah, I think it's time to close the meeting.
Well,
Okay, guys.
Out the nebula.
thanks, guys.
See you.
Thanks.
Good night, everybody.
Thanks,
It was
everybody.
great. Good meeting.
Yeah,
Thanks, Tom.
it's fun.
Later.
Yeah. Okay.